Assalamu alaikum everyone. Today we are going to discuss about a topic which is vector grouping of three-phase transformer. So at first we need to know some things which is a previous knowledge of us. This is please look at the screen, computer screen. Okay, this is what we are going to discuss today. So first thing is, if we have a three-phase Y connection, then what will be the relationship between line-to-line voltage and phase voltage? We already, every one of us already know that the line-to-line voltage will definitely will be greater than the phase voltage, and it will be √3 times greater than the phase voltage. So what will be the relationship between their angles? Definitely we already know that. Still I'm going to discuss today because it will be uh, needed later on for this class. So this is a three-phase connection. There is A, B, C phase. There AN is a voltage. From A to N, VAN phase voltage. VBN another phase voltage. VCN another phase voltage. AB is a line-to-line voltage. VAB. VBC is a line-to-line voltage. VAC is another line-to-line voltage. So what will be the relationship between phase voltage and line voltage? Suppose VAB is a line to line voltage. It will be equal to VAN plus VNB, which is written here. So VNB, what can we write about VNB? VNB is equal to minus VBN. VBN. So VAB equal to VAN plus minus VBN. If we add these two vectors, we can get line to line voltage VAB. These two phase voltages will sum up to line voltage. Now we are going to draw the vector diagram. This is the vector diagram. VAN is along the x-axis, so VBN will be 120-degree lagging, VCN will be another 120-degree lagging. Now VAB will be VAN plus minus VBN. VAN minus VBN is along this direction, so minus VBN will be along this direction. This is minus VBN. If we add VAN and VBN, we will get the resultant VAB. So from this picture we can see that VAB, the line to line voltage, is 30-degree leading of VAN, the phase voltage. That means line to line voltage leads phase voltage by 30 degree. This total angle is 60 degree. Okay. I have written here again. Now another thing we need to know to go through this class is about the clock. A clock has 12 hands indicating 12 hours. Okay, this is the picture of a clock, like 12, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We are familiar with this idea. Now you can see that from 12 to 12 we cover a circle, so it is 360 degree. This is 360 degree. If we divide 360 degree by 12 portions, we will get 30 degrees. So from 12 to 1 there is a 30 degree space difference. From 1 to 2 there is 30-degree space difference. From 2 to 3, there is 30-degree space difference. And if we want to travel 120 degree from 12, we have to go 430 degree, like 1, 2, 3, 4. Total 30 plus 30, 60. 60 plus 30, 90. 90 plus 30, 120 degrees. So if we travel from 12 to 4, we will travel 120 degrees. If we travel from 5 to 9, we will travel 120 degrees. Now we are starting our today's lesson. So we have already known different types of three-phase connection. What are the possible connections? In simple ways, the possible three-phase connections are Y-Y connection, like primary is Y, secondary is Y. Del-del connection, primary is delta, secondary is delta connected. Secondary windings are in delta connected. Another Y-D connection, primary is Y, secondary is delta. Then second, primary is delta, secondary is Y. But this is not enough information. If we indicate in a transformer's data sheet that it is a YD connected transformer, it is not enough. Because if we need to parallel it with another transformer, definitely we cannot parallel it with a YY connected transformer or DD connected transformer. We have to connect it with a YD connected transformer. But this is not enough. We need another information if we parallel it with similar types of transformer. This another information is the phase difference between this primary secondary line to line voltage, angle difference between primary secondary line to line voltage, and this number written after the connection, this 0 or 6 or 2 or 10, indicates the angle difference. So if we have a YD1 transformer and we want to parallel it with another three-phase transformer, definitely it will have to be a YD transformer, but we cannot parallel it with a YD5 transformer because this number is different. So it means their angle difference is different. Angle difference is different. So definitely there will be a circulating current that will cause problems to the transformer. So how to read this? If there is a YY connection, there are possibly two connections, YY0 and YY6. So what does this 0 and 6 means? 0 means the angle difference between primary line to line voltage and secondary line to line voltage. So if there is no angle difference between these two voltages, then the written number is 0. So if it is Y6, that means it is not 0. So that means primary secondary line to line voltage has an angle difference. What that is indicated by 6. So 6 means what? 6 means we have to go to the clock. 6 is along this line. This means one line to line voltage, like primary line to line voltage, is along 12 and another one is along 6. So angle, what will be the angle difference? Angle difference would be half of the circle, which is 360 degree divided by 2, 180 degree. So angle difference between primary secondary line to line voltage is 180 degree. So there are some different types of DD connection: DD0, DD2, DD10, DD6, DD8. You can always calculate like DD8. DD8, for DD8, the primary line to line voltage will be along 12 and secondary line to line voltage would be along 8. So angle difference is 30 plus 30, 60, 90. another 30, so 120 degree. The angle difference between line to line voltage of primary and secondary is 120 degree. Okay. So there are YD connection. YD possible YD connections are YD1, YD5, YD7, YD11. Same for DY connection, DY1, DY5, DY7, DY11. Now we are going to try how to connect windings in DY7 connection or DY11 connection or YD5 connection. So in two different ways we will face this problem in your life. One is during the final examination, we will ask you to sketch the vector diagram and connection diagram of DY11 configuration of a three-phase transformer. Another problem you will face when you are in practical field. When you are working as an engineer, you have to connect two transformers in parallel. So you have to read the data sheet, you have to know the connection of this transformer, then you have to parallel it with a similar type of connected transformer. So this is it. Or it may be you work in a manufacturing company, so you are connecting the transformer is prepared from the factory and you have to indicate its connection in the data sheet. So how do you do it? You go through the connection diagram of it and you decide it is a YD connection, YD1 connection or DY11 connection. Then you will write it in the data sheet. So how do we determine or how do we draw? Okay. This is the question was for us was do you sketch the vector diagram? We have to show all kinds of voltages like primary side line to line voltage, primary side phase voltage, secondary side line to line voltage, secondary side phase voltages in the vector diagram. And we have to show the connection diagram, how the windings are connected. Primary side 3 windings, secondary side 3 windings are connected in DY11 configuration. First, we need to know what is DY11. We already know that. Right? So, what is D? D means delta connection. And we see that the D is capital D. That means high voltage side is delta connected. High voltage side. Capital D means high voltage side. Why? Low voltage side is Y connected. We already know that before connecting a transformer, we cannot know for sure that which one is primary, which one is secondary. We just know that which one is high voltage side, low voltage side. When we connect it with the power system, then we can say that the winding which is connected to the power supply is the primary side, and the winding that is connected to the load side is the secondary side. So now this, what does this 11 means? 11 means D voltage of D connection, the line to line voltage of D connection. This is VAB. I have written it in AB, capital AB. Voltage of line to line in high voltage side is along 12 of the clock, and the secondary side, or sorry, the low voltage side, line to line voltage VAB is along 11 of the clock. So the reference is never indicated, like D12Y11 is never indicated. We already assume that the high voltage side is along 12 always, but we will indicate at which direction the secondary or low voltage side line to line voltage is, that is 11. 11 of the clock. As you can see, there is 30-degree angle difference, like 11, then in the clock 11 is just before 12, so there is 30-degree angle difference between primary and secondary or high voltage and low voltage side winding. Now back to the lesson. Okay, how do we draw the vector diagram and connection diagram? First step is drawing the vector diagram. Drawing the vector diagram. So we already know the high voltage side is in reference direction, which is 12. I have drawn it like VAB is along 12 of the clock. Now, second step is we have to draw all the other line-to-line voltages of the high voltage side. If VAB is along Y direction or 12, VBC will be 120 degree apart from it. So VBC will be in this direction. I have drawn it here from 1 to 120 degree 12. We have traveled 120 degree from 12. So VAB is along this direction. VBC, another line to line voltage of high voltage side, is along this direction. VCA is along this direction. All are line to line voltages of high voltage side. See that I have indicated the clock points. We already know if we go from 12 to 4, we will travel 120 degree. If we travel from 4 to 8, we will go 120 degree. 8 to 12 is another 120 degree, total 360 degree. Okay, now we have to do the phase voltages. Phase voltages, like we have discussed before, we have to draw all the phase voltages, all the line voltages of primary secondary side in the vector diagram. Then we will complete the vector diagram and we will be able to draw the winding connections. Now our primary was or our high voltage side was delta. So we have drawn the line to line voltages. Do we need to draw the phase voltages? No, we do not need to draw the phase voltages, because in delta connection, line voltage and phase voltages are the same ones. Now delta side is completed. We have to go to the low voltage side, that is Y connected. So in low voltage side, we have already some information, which is the Y voltage side is along 11. The Y voltage side or the low voltage side line to line voltage VAB is along 11. If we know VAB is along 11, in which direction VBC will be? We have to go 4 points to travel 120 degree. 4 points is from 11 to 12, 30 degree, 60 degree, 90 degree, 120 degree. So now along 3 in the clock, we will find VBC, the line to line voltage of Y connection. See, I have written in small letters because it is low voltage side line to line voltage. Now VCA will be from 3 to 4 points lagging. 3, 30 degree, 60 degree, 90 degree, 120 degrees. So VCA will be along 7. Now we have completed many parts of our task. All the line to line voltages of the high voltage side and low voltage side is drawn, and phase voltages of high voltage side is line to line voltage of the high voltage, so we do not need to worry about that. The next task is drawing the phase voltages of the low voltage side. We have to go through the information which we have discussed at the beginning of our class. That is, in Y connection, line to line voltage leads phase voltages by 30 degree. So in our phase vector diagram, VAB, the Y connection line to line voltage is along 11. So in which direction phase voltage VAN will be in 30 degree lagging direction. So we have to go from this point to 30 degree lagging. We will get this direction. So VAN will be along 12. VANY will be along 12. That's it. Then if we can plot VAN, we can plot VBN, VCN. We have to go 120 degree from each other. From 12 to 4, there is 120 degree difference. So definitely VBN will be along 4, VCN will be along 8. Now this is the complete picture. All the phase voltages and all the line voltages are drawn. You will get 50% marks if you complete this task. So I have to remind you something here for your understanding purpose. I have drawn it for step by step, and I have written some comments along the way. When you are answering in your script, you do not need to go through all the steps. You do not need to draw step by step diagram. You just need to draw this final diagram. You just need to draw this final diagram. You will get 50% marks if you draw this. The next 50% will be achieved by drawing the connection diagram. Now, the second step is how can we draw the connection diagram. First step is drawing. We know this is a three-phase transformer, so definitely there will be 3 windings in the primary side or high voltage side, and there will be 3 windings in the secondary side, in the low voltage side. I have drawn it. I haven't drawn the Y connection or delta connection yet. This is the 1 winding, first winding, second winding, third winding for high voltage side, first winding, second winding, third winding for low voltage side. The next step will be whichever side is Y connected, we can mark it first. We have to mark it first. For us, the secondary winding is Y connected, like the example given to us is DY11. So the secondary low voltage side is the Y connected winding. So we have to mark this side. So Y connected marking will be AN, BN, CN. And then we will forget this HV side, just look at the low voltage side. we will connect a winding to a point. This is our A point for low voltage side. In all the ends are connected or shorted together to create the neutral line. B winding is drawn from here, Q is drawn from here. So Y connection is easy for any kind of connection like DY or YT. We will always draw the Y side first, mark it as AN, BN, CN, then we will add the N points and draw out the ABC point. The trick is at the delta connection. Delta connection is, okay, look at this. This is the volt. From A point to N point, there is a voltage, which is what? VAN. The voltage is VAN. So this voltage is induced due to this winding. The voltage induced in this connection, in this winding, is due to this voltage. So we already know that in transformer, the primary and secondary voltages are always in phase. They will indicate their direction will be in the same direction. The voltage in this winding will be in phase with the winding voltages in this winding. So there is, in this winding, a voltage will be applied which will be in the same direction as the voltage induced in secondary, which is VAN. So we have to go to the vector diagram. This is our vector diagram. So VAN is in 12 direction. Which voltage in of the high voltage side is in this direction? That is VAB. So due to VAB, we applied in the D direction VAB voltage and we get VAN in the secondary because they are in the same direction. I want to remind you that you cannot say that we have applied a voltage VAB which is in 12 direction and we get a voltage VBC which is in 3 direction, because there is an angle difference. The voltage applied and the voltage induced will always be in the same direction. So the from when we are drawing the connection diagram, we have to focus which two vectors from primary and secondary are in phase. They are each other's supply and induced voltage. So VAB, so from this idea we can say that the voltage for which AN is induced is VAB. Also VBN is induced from the vector diagram. VBN is induced due to VBC. VCN is induced due to VCN. After the marking of the high voltage side or delta side, we will add all the A's together. A, here is an A, here is an A. So we are connecting these two by a wire. This is our final A point. All the BB together, all the CC together. We have drawn out a B point. We have drawn out a C point. This is our transformer. We have able to draw the connection. So again, if you draw only this diagram, just you have to draw this diagram only, you will get another 50% marks. You do not write these lines. You do not need to write these lines. these lines to or these diagrams. Okay. Now I have given you another problem, which is sketch the vector diagram and connection diagram of YD5 of a three-phase transformer. Here, Y means the high voltage side is Y connected, secondary or low voltage side is delta connected. Y is in line to line voltage of Y is in reference direction, which is 12 of the clock, and the voltage line to line voltage of D is in 5 direction, like 5 of the clock. We have to draw the vector diagram. This is how you answer in your script. You just need to draw them. You do not need to explain anything, or you do not need to draw them in step by step. This is VAB, Y connected, that is high voltage side, line to line voltage along 12, along 4, along 8. And VAB is along YD5. So VAB, which is delta connected, AB is along 5. 5 plus 4 equal to 9, along 9. 9 plus 4 equal to 13. That means 1 after 12 along this direction. VCA, VAB, VBC. All the delta connections are done. We haven't done the phase voltage of the Y connection yet. So we know the Y connected phase voltage lags line voltage by 30 degree. This is line voltage, so 30 degree lagging. This is the phase voltage VAN. 1 plus 4 equal to 5. VBN, 5 plus 4 equal to 9. VCN. This is the complete diagram. Here I have indicated for which voltage of Y connection voltage of delta connection is induced. For VAN, we see that along VN, the two vectors from primary secondary are related in this point. VAN and VCA are in the same direction, Y delta. So because of VAN, definitely VCA is induced, or we can say for VCA, VAN is induced. So VAN, VCA are one another's supply and induction. Another two voltage from primary secondary are related here, VBN and VAB. So VBN is related to VAB. VCN and VBC are related to each other. So now we have to draw the connection diagram. This is the connection diagram. First, we have to draw 3 windings. 1, 2, 3, 1, 2, 3. Now we have to draw the Y connection. Like we have to mark them. AN, BN, CN. We have to connect all the N. A is drawn out here. B is drawn out here. C is drawn out here. Now, from the vector diagram, we see that VAN is related to VCA in delta side. So we have to write CA here. VBN is related to VAB. We have to write AB here. Then VCN is related to VBC. We have to write it here. Now we have to add all the A. This A and A connection, B and B connected, C and C connected, drawn out A, drawn out B, and drawn out the C points. This is a delta connected side, this is a Y connected side. Now, your assignment for today's class is draw YD5 vector diagram and connection diagram. This is not the always, this is sometimes I can give you these two connection diagram, like these vector diagrams, not this YD11 or YD12 point, just this clock diagram, and I can ask you to draw the connection diagram and the connection name. Like you have to mark it, you have to go through it, then you have to decide it is a YD5 connection, then you have to draw the connection diagram. Okay, that's it for today's class. We will see you not hopefully after the pandemic is over, we will see each other inshallah. Assalamu alaikum.